So now we are going to study important topic which is shape factor. Shape factor F12 means कि 1 से 2, 1 से 2. F21 means 2 से 1. A1 F12 is equal to A2 F21, and it can be written for any surfaces, any number of surfaces. Suppose there are 3, 4 surfaces or 5 surfaces. You can still write A1 F12 is equal to A2 F21. No matter how many surfaces are there. Tapered surfaces is just nothing. F11, suppose this is 1, F11 will be equal to 0. Yes. Take radiation per not a straight line and see if it falls on that same surface. Concave, cave. For concave surface, F11 is not equal to 0. There is a chance of radiation falling on itself. If the surface is bounded by symmetrical surface, then shape factor is same. Suppose these are 3 surfaces. I am talking about surface area, not okay, I will explain. Suppose this is the first surface, this is second surface, and this is third surface, and length are same and orientation is also same. So F1 1 2 3, F12 will be F21, F23 will be equal to F32, F13 equal to F31, and yes. As I said कि अगर orientation, length, ये सब orientation is important and length is also important. Both are important. Then only shape factor will be same. Suppose this length may be same, but if orientation is not same, then you cannot write F12 is here. This length is equal to this length. So you can write F12 is equal to F21, but you cannot write F13 is equal to F31. You cannot write F32 is equal to F23. You cannot write this. But you can write it for any surface. Radiant heat exchange between two bodies. This is formula for steady state heat transfer between दो bodies के बीच में steady state heat transfer. और यह है net value, मतलब of course you know net, क्योंकि एक body emit भी कर रही है, उस body पर आ भी रहा है. This is the net means net entering on each body. How question will be asked? 1 to surface. If asked radiation heat transfer from 1 to 2, understand the question. He has not used the word net. He has just asked radiation heat transfer from 1 to 2 means F12 sigma epsilon 1 A1 T1 raised to 4. He is talking about. Just falling on 2 and not radiation heat transfer from 1 to 2 means कितना गिरेगा. Of course absorb होगा, वो मेरे को नहीं लेना है. And heat transfer from 2 to 1 is equal to emissivity भी आएगी E2. ठीक है. This is from radiation from 1 to 2. This is from 2 to 1. But if asked find the net radiation heat transfer between 1 and 2, then formula will be this. This is formula of net heat transfer between 1 and 2. Now this is the important discussion. Remember, heat is a scalar quantity. So what you can write, suppose this is the first surface and this is the second surface. So you can normally write A1 F12 is equal to A2 F21, and you can write F11 plus F12 is equal to 1. No problem. Now you have written this. Suppose I divide this surface 2 into 2 parts, 3 and 4. Then what you can still write? What I can still write is, remember heat is a scalar quantity. It can be added. So A1 F12 represents दिस इज फॉर अंडरस्टैंडिंग A1 F12 रिप्रेजेंट कि 1 से 2 पे कितनी हीट गई. Naturally it does not mean that, but for understanding it let us consider it means that A1 F12 1 से कितने 2 पे गए is equal to A1 F13 1 से 3 पे कितनी गई प्लस A1 F14 1 से 4 पे कितनी गई. Of course balance heat this. Now you can also write, as I said, you can write for any surface, you can write A1 F13 is equal to A3 F31 and A1 F14 is equal to A4 F41. This which I did just now was कि अगर जिस सरफेस पे रेडिएशन आ रहा है वो अगर दो पार्ट्स में डिवाइड हो तब वो आता है, बट जिस सरफेस से अभी रेडिएशन जा रहा हो अगर वो दो पार्ट्स में डिवाइड है तो क्या. पहले इनिशियली ये केस था, सो वी कैन राइट A1 F12 is equal to A2 F21. Correct. Now we know heat is a scalar quantity, so this is radiating surface, ये इससे रेडिएशन करेगा. So E3F32 heat is a scalar quantity plus A4F42 is equal to इनिशियली ये जा रहा अभी इस पे और इनिशियली कितना जा रहा था इससे इस पे A1 F12 A3F32 plus A4F42 is equal to A1 F12. ठीक है. Suppose this is the statement figure which is given and maybe asked anything. So I will write all the equation which can be written. I can write. Don't fear of orientation. A1. Suppose this is the whole surface as 4. A1 F14 is equal to A4 F41. This I can write. I can also write A1 F14 is equal to scalar quantity. So A1 से F 12 प्लस A1 से इस एरिया से 2 3 पे, सॉरी हाँ मतलब 1 से 3 पे. दिस आई कैन आल्सो राइट. Yes, this I can write, no fear. This I can write as A4 F41. I can write it as, इसको अगर स्प्लिट करना चाहो तो 4 से 1 पे ना तो A3 से F31 प्लस A2 से F21. This I can also write. A3 F31 plus A2 F A3 F31 plus A2 F21 is equal to A4 F41, which I just wrote. You can write this A1 F12 is equal to A2 F21 any day. You can write A14 is equal to A41. ये तो सब सिंपल है. Okay. A1 F14 is equal to A1 F12 plus A1 F13. Yes. Now suppose this is the question. This surface is 5 and this surface is 6. Both are split. And actually what is asked is find the heat transfer between A1 and A2. Nothing. You just find F12 and use the formula sigma T1 raised to 4 minus T2 raised to 4 upon 1 minus E1 by E1 A1 plus 1 upon A1 F12 plus 1 minus E2 upon E2 A2. Don't worry, just write this formula. You have to just, at the moment you have to find F12. You have to find F12. But as I'm solving the question, I'm going to find everything. So you can write here A6F65 is equal to A5F56. Yeah, you can write A6F65 as 6 से 5 पे मतलब 6 से 5 पे मतलब A6F65 is equal to 6 से 5 मतलब 6 से 3 प्लस 6 से 1, 6 से 3 प्लस 6 से 1. You can write like, or you can write this like A5 से F5 4 प्लस A5 से F5 2. Okay, you can write like this. Okay, you can write individually like A1F12 is equal to A2F21. Individually you can write everything. Remember, heat is a scalar quantity. You can write anything. A1F14 plus A1F12 plus A3F34 plus A3F32 is equal to 5 से 6 मतलब A5F56. Heat is a scalar quantity. Or you can also write A4F43 plus A4F31 A4F41 plus A2F23 plus A2F21 A2F23 plus A2F21. You can write like this is equal to A6F65. Heat is a scalar quantity. You can write anything that you want. Just summation, it's nothing. Because इस 4 की हीट यहाँ भी जाएगी, थोड़ी यहाँ भी जाएगी, और 5 की भी यहाँ भी जाएगी, थोड़ी यहाँ भी जाएगी. You can write like this. And writing that like कि F44 plus F42 plus F43 plus F41 plus F4 surrounding is equal to 1. This is not going to be useful here. Of course 4 का 2 पे भी जा सकता है. Of course 0 होगा और 4 भी 0 होगा, थोड़ा इधर जाएगा, थोड़ा इधर जाएगा, प्लस थोड़ा सराउंडिंग में भी जाएगा. So वो इक्वेशन यहाँ पे यूजफुल नहीं होने वाली, समेशन वाली. But all these are going to be useful. These are the further solutions. If you want to retry it, how not to calculate unnecessary data in this question. To not calculate unnecessary data, go step by step. What is first, see what is given in the question, what values are given in the question, and the values which are given in the question, how they are going to be useful in question solving. Now defining one other term, it's radiosity. Radiosity का मतलब radiation living. Of course frequency living, radiosity में भी तो ये होता है frequency living, which is denoted by J. Total radiation leaving the surface, इसका मतलब क्या होता है? Suppose this is the surface 1 at temperature T, having emissivity E1 in area E1. Now total emission leaving मतलब खुद का, पहले खुद का क्या लीव करेगा? Just leaving, I am saying just leaving. Leaving कौन सा होगा? Not striking on other, just leaving. Leaving मतलब F12 नहीं आएगा फिर. ये इसका खुद का गिरेगा और लीव कौन सा करेगा? जो दूसरे सरफेस से आया, जो यहाँ पे एब्जॉर्ब ना हुआ और रिफ्लेक्ट बैक हो गया, दूसरे सरफेस से यहाँ पे आया कितना होगा? F21, उसकी खुद इमिसिविटी सिग्मा A2 T2⁴, ये तो खुद यहाँ पे इमिशन करके यहाँ पहुँचा. अब ये रिफ्लेक्ट बैक कितना करेगा? इनटू रो कर दूंगा तो ये रिफ्लेक्ट बैक इतना करेगी. So the radiosity is equal to E1 sigma A1 T1⁴ plus rho F21 E2 sigma A2 T2⁴. So this is the radiation leaving. एक सेकेंड, why I have written alpha? Alpha means absorbed. Rho denotes reflectivity. Rho denotes reflected back. So this is all. Remember, for black body there is reflectivity is equal to 0. I forgot to tell you one thing. The equation C1 e raised to minus 5 upon e raised to C2 lambda t minus 1, this equation are valued only for black bodies. This equation were derived only for black bodies. So we find इंटीग्रेशन से हम जब फाइंड करते हैं वो सिर्फ ब्लैक बॉडी का वो देगा इमिसिव पावर. वो तो हम लेटर ऑन वी डेवलप्ड अ कॉन्सेप्ट ऑफ इमिसिविटी. Remember, the term 1 minus E1 upon E1 A1 is called surface resistance, and the thing 1 upon A1 F12 is called space resistance. These cases are going to be very important. Two body enclosure 1 and 2. A small body kept in a large enclosure. It means area 1 is very less than area 2. This means A1 by A2 is almost equal to 0. So how this is going to be useful is like this. If suppose a very small sphere is kept in a very large cube, so you take a reciprocal of you take A2 common, here you will get A1 by A2 and this will become 0. Two very large plates, the equation becomes like this, and this is a very important question. For two plates having same emissivity, this is the equation. Yeah, this is the equation for this. Radiation shield between two parallel plates. इसका रेजिस्टेंस सरफेस रेजिस्टेंस, इसका स्पेस रेजिस्टेंस, इसका सरफेस रेजिस्टेंस, इस साइड का सरफेस रेजिस्टेंस, इसका स्पेस प्लस इसका सरफेस. नाउ द फाइनल इक्वेशन कम्स आउट टू बी लाइक दिस. अगर एक शील्ड है तो रेजिस्टेंस हो जाता है 4/E2 माइनस E2, मतलब ट्वाइस ऑफ अगर सिर्फ प्लेट होती दो. अभी हमने यहाँ पे निकाला था, पीछे निकाला था, ये देखो. अगर सिर्फ दो प्लेट होती तो इतना आता है हीट ट्रांसफ़र, और अगर एक वो लगा दिया जाए तो हाफ हो जाएगा. इसका मतलब Q विथ शील्ड, Q विदाउट शील्ड होता है X, तो Q विथ शील्ड होगा X/2, मतलब Q विदाउट अपॉन Q विथ हो जाएगा हाफ, विथ और विदाउट. सो अगर हम दो शील्ड लगा देंगे हो जाएगा 1/3. अगर हम तीन शीट लगा देंगे हो जाएगा 1/4. चार लगा देंगे हो जाएगा 1/5, मतलब 1/n+1. हीट ट्रांसफर Q विथ Q विदाउट is equal to 1/n+1 when n represents number of shields. This equation is valid if emissivity of all the shield two plates are same. ये तब equation valid. Now question solving will be done.